That sounded like a UFO or something.
What do UFOs sound like? That apparently.
We're going to get rid of that phone. Let me go kill a telephone.
Okay.
Hey, Scott, Kent, Annie,
Hey, Cameron.
Hello, Cameron.
how you doing?
I'm holding this chair down very well.
Awesome.
Actually, you know, in the world of quantum physics, you're actually floating above your chair. With the, you know, the repulsion of the atoms. You don't actually really touch it. I guess if you touched it, you would just absorb yourself right into the chair.
So would that make the chair human then?
Who knows? That would be a socio-political, you know, controversy that we don't get into on these programs.
Or metaphysics, right?
Yeah, that's right. Or metaphysics. What is the old joke? I never met a physical I didn't like. Something like that.
What?
I'm sorry.
What?
I am sorry.
I think that's a proctologist joke.
No. No. This is a family show. Big day tomorrow, personally and in general. That's great. Right, Ms. Byrne?
On the hottest planet in the solar system, a probe descends through a thick, poisonous atmosphere. It is both a time capsule and time machine, unlocking secrets of the ancient past while revealing how a world can turn from possibly habitable to horrible. The location? Venus. Our sister planet has much to tell us about our own and exoplanets, helping ignite a scientific renaissance for our universe. The mission, brought to you by NASA Goddard and its partners, is aptly named Da Vinci Plus, the first U.S. probe mission to Venus in over 40 years. With the probe acting as chemistry lab and photographer, other cameras will map and gather additional views of the planet from above, providing a new study of Venus that has scientific implications well beyond our own solar system. Da Vinci Plus will give us a new understanding of planetary evolution. Launching in 2029, 3 years will be spent exploring our celestial neighbor. Da Vinci Plus, coming soon to a planet near you.
Well, hello, everybody. We've got a really special show today. The special guest joining us is Tom Meneghini, and he is the director of Mount Wilson Observatory. I think maybe contacting us from either home or at the Carnegie Institute. So I'll bring Tom on, but we're going to be talking a little bit about Mount Wilson Observatory and the programs that they got going on this year. We are a big supporter of Mount Wilson. We love what they do there. It is the cradle and of the not only the term of astrophysics, but where the whole activity of it was born. It is the second and third largest telescopes in the world, built by George Ellery Hale, is there, and they have an interferometry program that goes on there that is world class. And Mount Wilson is a place, when you go there, you feel the history, but you can experience astronomy and all of its wonder, when you go to this place. And we hope to be there next year with our own special excursion. But Tom wanted to talk about what's happening in Mount Wilson now. So I'll turn it over to you, Tom.
Oh, thank you, Scott. This is a corner of my living room. This has been world headquarters for the observatory for the past year and a few months. We've been through a pandemic and a fairly close call with a big fire, the Bobcat fire, last fall. So we came out unscathed, but we haven't had any programs operational or viewings or tours like we normally have. So we have a whole cadre of volunteers and people who are a little rusty out of practice, including yours truly, to open up the season, which we plan to do on the 15th of this month, June 15th, when COVID restrictions in the state of California are to be relaxed. We don't know what that relaxation is really going to be, because that's the state, but there's also the county and also local regulations that could be imposed that would impact the way we do things. But we've decided we're going to open and we're going to play it by ear. So we'll be making adjustments through the season. We don't know exactly how the public is going to receive this, because we have many types of events. We have classically our telescope viewings through the 100-inch and the 60-inch telescopes that are available. They'll be available tomorrow for general bookings for you who are interested in coming up there. We have concerts in the dome. We have string concerts. We had a jazz concert a few years ago. We're trying to get them back again, but we have lectures. We had lectures every month in 2019, none of them last year. We'll probably get 4 or 5 off this year. And then we have our tours, the general public tours. We have an engineering tour where our volunteer engineers take you through all the machinery on the mountain, which is an excellent tour for you mechanic geeks like me. I like this stuff.
Oh, yeah.
So we have a lot of things to pull together. and get going again. We're rusty, but we'll get running here very soon.
Mm-hmm. Now, for those of you who follow me on Facebook, you know that, well, you might have heard that yesterday was my birthday. So I gave I put up for my birthday a Facebook fundraiser for Mount Wilson Observatory, and I had a challenge of $1,000, and I'm happy to say that we met that challenge. I just checked a few minutes ago, and so we were able to do that. I think some people from around the world actually contributed to this. So if you are so inclined, Mount Wilson does run off of donations and volunteer activity. If you've never been, it's someplace, it's definitely a bucket list place to go to as an astronomer. You have to go to the place where they discovered the expansion of the universe, so. But you can go to their website. I've put it up on the chat at mountwilson.org, and there'll be, any contribution goes to help this venerable and historic institution. So the other thing I guess we should talk a little bit about, Tom, is the Alliance of Historic Observatories. And we had a historic meeting. It was historic, being there under the 100-inch dome with people from Lick Observatory and the Vatican Observatory and Griffith Park and Palomar. I'm sure I'm missing someone here, but Lowell Observatory and Yerkes Observatory as well was in that initial meeting. And now you'll find that the organization, although, there was a little bit of a slow start, I would say, because of the pandemic. But there is now a website up, and, I look forward to more activity, at Mount Wilson, at Mount Palomar, at Lick, and all these observatories who have joined together. I don't know if you have any updates on that, Tom, but I'm real proud to have taken a little part in it myself, and I can't wait for more activity to get started.
Well, I hope it gets some traction this year. I think 2020 was pretty much a write-off. We lost a lot of time doing a lot of things, and that's one thing we neglected as well. Well, we'll be really pleased to get back into the swing of this and get our association working again, or at least cooperating more closely to get strategies for all of us to survive. Right.
So if you're interested in visiting Mount Wilson, definitely visit their website. Attend one of those great concerts that they have. They have incredible speakers from the Carnegie Observatory that come up there. Be a part of the ongoing inspiration that is Mount Wilson Observatory. Okay, Tom, thank you so much.
Okay.
We're going to segue
just one more comment.
Sure.
You said that you could feel the history up there. Well, you can come up there and touch it.
Yeah, that's true. That is true. That is true. I don't know, Tom, everybody I've talked to that has been up there, when I talk about, the feeling of the history that's there, this kind of living history, it's a vibe that it's I don't know how else to describe it. You feel it there, and you also feel it at Yerkes when you go there too, so I don't know if it's the phantoms of all these great astronomers that were up there, or just it's there.
It's the legacy of George Ellery Hale.
It is. It sure is.
All of the sites have that feel to them.
Yeah, that's true. That's true. I guess there's a couple of ghost stories that go along with that too, but we'll share that at another time.
I'll tell you mine later.
Oh, yours. Okay, we'll have to have Tom back on. All right, that's great.
Thank you, Scott.
Thanks, Tom. Take care. Bye-bye. So, Annie, we're going to transfer over to you. How are you doing, and how is life in the Explore Alliance?
It's pretty amazing. We currently have about, I finally finished verifying most of our memberships. So
Okay.
we have almost 1,100 members.
Okay.
Our standard membership is expired, so I'm going to start calling this week calling those customers and seeing
Oh,
those
sure.
members and seeing what they want to do. We'll always slide them over to Legacy, but if they're wanting to upgrade, we'll do that as well. So just giving them that option. We have had a couple of people reach out about ambassadorship. I'd like to kind of touch note on that.
Okay.
We are, our main focus is about educational outreach. So our ambassadorship is not a brand ambassadorship. It is solely about educational outreach. So we want to know what a person is doing, and we want to know their track record and their history on the outreaches that they have done in their community. And so, that's just. I just kind of want to clarify that a little bit, because we're unique in that we don't focus solely on what gear a person is using.
Right.
We want to hand down that knowledge of astronomy down through the generations, and so that's our goal, is to educate people and to be able to have that knowledge passed down. And so. Anyway, so I'm excited to see what members are doing, to see what kind of outreach that they have, and just learn more about our members and how they're transferring their knowledge to somebody else.
Right.
So yeah. So
there are people, I know there's people that reach out. I mean, of course, we're a telescope manufacturer and everything, and there are people that reach out to us and say, hey, make me an ambassador. If you send me some equipment, I'll ring the bells for Explore Scientific. That's nice, but that's not what we do, here.
That's right.
Explore Scientific does, we do our job. We try to make great product at a great price and give great service behind it. But the programs that we do through our Explore Alliance, as you said, they are educational outreach programs. And, so it doesn't matter if you're using a homemade telescope, a Celestron, a Meade, astrophysics, whatever, or even something very modest, as far as a telescope goes, a small 60 millimeter refractor and stuff. There have been people who have done incredible outreach with small telescopes. Galileo is one of them. Okay. And you can't start too young either, or too old or too young. We have, tonight we will have two 11-year-old girls on the Global Star Party, and they'll be talking about their experiences at space camp, their knowledge of astronomy. So Libby will be talking about the Cygnus constellation, and a newcomer. Libby's given, 40 presentations already on Global Star Party. But Sabella Burlingame will be on tonight, and she'll be talking about her experience at Space Camp, which is pretty cool. So I wish I'd gone, as a kid. I wish they had it when I was a kid. And maybe they did. I don't know. But, this is when dinosaurs roamed the earth, and, way before there was, the space program was just actually getting going. Anyhow, well, that's great, Annie. Anything else special happening that you're aware of, or is that kind of where we're at?
That's kind of where we're at. We just sent out to our members the Binoviewer that we launched. They get that special or platinum, because they get that first dibs and stuff. And so I think that email just went out this week. But I'm interested in what our members want and what they're looking for. And so if they want to email us, at Explore Alliance at explorescientific.com, we can do that, or you can email me at annie@explorescientific.com. I'd love to sit down and see what our members are doing. I love how our program highlights them, not us. It highlights them and what they're doing to share their knowledge with others. So,
Yeah.
but yeah. So,
Very
yeah.
cool.
Yeah.
Very cool. Annie, thank you very much. Thank you.
Thanks.
All right. So earlier, Kent and I were talking about what would be on the FirstLight Chronicles. You know, Kent is now, this is his 40th FirstLight Chronicles show episode. And so you kind of want to do something a little bit special. FirstLight Chronicles is really about, you know, how to get started observing, how to use modest equipment to get going. You know, we went through the Universe Sampler with the Astronomical League. We've done a number of things. I think today you wanted to talk about, what was it, overlooked constellations?
Yeah, some overlooked constellations. But first, I'm going to, you know, this is our 40th, at my 40th episode. So I am going to give away a 52-degree, 40-millimeter eyepiece.
Wow.
Surprise,
Okay.
Scott. I get to spend your money. So
Our money.
our money. Yeah.
Yeah.
So we get to give a little bit back to the customers who own the company. How about that?
Yeah.
So this is a question for Explorer Alliance members. You have to be an Explorer Alliance member to win these prizes.
Okay.
So this is a very difficult question.
Okay. And they're going to email their answer to Explorer Alliance at explorescientific.com. I'll put it
That's
in the
right.
chat again. Okay. Don't put the answer in chat. Okay.
Well,
Because-
you can put the answer in chat because this is one for everybody.
okay.
This is everybody.
But only one person can win an eyepiece, right?
Right. We just, you know,
Okay.
if we have 25 people answer it, you know, by 10 a.m. tomorrow,
Yeah.
and we'll just put those 25 names in order as they came in an email, use a random number generator, and bingo, that person
Pull a rabbit out of a hat. Okay.
pulls the lepus out of the ophicus, if you will.
Yes.
So the question is, what's your favorite constellation and why? Now, I don't need a 10,000 word outline, but what's your favorite constellation in a few words? Why? Just to see,
Okay.
you know, what people talk about. Real simple,
Okay.
you know, and I thought about it because we're
Right.
talking,
That is something for everybody.
and it's something for everybody. So
You can't lose this way, but you have to
Correct.
you have to get lucky that we pull your name out. What would be fun, Kent, is on the next program for the winning person. Let's
Sure.
read their
Absolutely. Great idea. We read 3 or 4 of them, the interesting ones that go on, because,
okay.
you know, it's hard to pick a constellation that's a favorite because there's so many. At the May meeting of Sugar Creek Astronomical Society, I did a constellation of the month talk on Corvus, which weirdly is, and I can't tell you why, but I like Corvus for some reason. There's almost nothing around it. It's little bitty. It's pretty low on the horizon, especially if you have trees. But Corvus is one of my more favorite constellations, and probably my favorite small constellation or overlooked constellation, which is what we're talking about today.
Okay.
But,
All right.
you know, lots of people are going to pick probably Ursa Major, the Big Dipper, Orion. You know, I really like Auriga, M36, 37,
Auriga.
38 there.
Sure.
I really like it. You know, they're beautiful in a small telescope. It's one of my favorites.
Sagittarius.
You
Yeah.
know, there's a lot to pick from. So I
Scorpio.
challenge people to whittle it down to one. All right. So let me go ahead and share my screen, and we will talk about overlook constellations. So this is at 10 o'clock tonight, actually 10:30 tonight, in Northwest Arkansas. And, you know, you can see all the constellations that are out there, and you see the big ones everybody knows. You know, right here, if you can see my cursor, is the Virgo cluster that Cameron has been showing a lot of images from with his iPhone or his smartphone photography. and comparing it to what star charts show. But, Virgo is a well-publicized constellation. Right here is Corvus. And, it's 15, 20 degrees above the horizon. If you've got trees, especially to your south, you're not going to see it. So it takes a little bit of effort to go out and see it. Crater is right here. It's not a bright constellation at all. Lupus, the rabbit, is down here right on the horizon for us. And people farther south can get a better look at it. But here, it's a very difficult constellation to see because it is so low in the horizon. And frankly, it's not up very long. Along with Centaurus, there's not a lot to see. All these constellations up here in the north, Lucretia is here, tiny little constellation, not much to it. Delphinius is just rising in the east. I'm using carts to seal, so we'll go ahead and step forward a couple hours to get Delphinius up a little bit more. So now we're at midnight now, and Lucretia's right here. Delphinius is hiding right here. It's the dolphin, and frankly, looks a little bit like a dolphin. And people often mistake it, along with Sagittarius, for the Little Dipper, which is, as hopefully you know, is always around the North Pole and always visible to our latitudes. You got Sagitta, which is a tiny little 2 or 3 star constellation that is just completely overlooked by most people. And then moving back here a little bit more into the southern sky again, Norma is a constellation that I've only seen a couple of times when I've been farther south, because we have so many trees here, you just can't see it. We technically here at 36 degrees north can see Ara right on the horizon, Corona Australis. So there's a bunch of these little smaller constellations that just sort of attracted my attention, thinking about, doing Corvus a month and a half ago, or a month ago, and I may try and start to look at some littler constellations, just because,
Delphinius and Eculus and
exactly, just all those little constellations that don't have any M objects close to them. They may have some really, faint fuzzies, on whatever, list, but Corvus just doesn't have anything. M104 is close to it, and using the sky charts, the Telrad charts I use, Corvus becomes the target stars to get your Telrad lined up with it so you can see it. And frankly, that's how I discovered Corvus, was trying to find M104. Not trying, but to find M104 for the first time after I had a Telrad, makes it, having the finder charts makes it, the M objects, a whole lot easier. So anyway, just want to talk about some of the minor constellations a little bit. And, a pair of binoculars, or a pair of, I think Ed Gunther, one of our friends, says the Mark I eyeballs is a very good optical device to use to look at constellations.
Mark I eyeballs, huh?
Yep. Everybody's got them. Most
of us do.
Some of them don't work as good as they used to. I noticed the astigmatism in my right eye is getting worse. I'm starting to see flares, on off of stars that didn't used to have flares. So that's no bueno. But when you go out, don't just look at the big constellations. Try and find those smaller constellations and learn where they are and see them for their tiny little beauty. And frankly, they had to come up with something to fill that small space. But the space in between the big constellations. But again, if you have never been to a dark sky site, talking about bucket lists, this should be on a bucket list, is to go to a dark site in the summertime, in frankly July and August, when the sun goes
you
down,
can really see the Milky Way,
and the Milky Way is overhead. It is astounding how many stars are up there. So when you go a couple of months, and I'm stepping this forward, and you get to where the Milky Way is like that, but at sunset, 2 hours after sunset. It is truly astounding what it looks like, and at Nebraska, I have seen my shadow by the Milky Way, this diffuse shadow on the ground. It truly is an amazing sight. And the weirdest thing was the sun went down and I was looking up. I couldn't find the constellations. There were so many stars.
So many stars. Yeah.
There were so many stars. The constellations disappeared.
Yeah.
The constellations are easy to find under moderate light polluted skies because they're the only stars that are left. And so the brightest stars are what you see. And a lot of skies, Corvus is going to disappear. Sagitta is going to disappear. Delphinius probably is not going to be there in many skies. So it takes going to darker skies. But if you ever get a chance to get down to a Bortle 2 or even lucky enough to get to a Bortle 1 sky, take that chance. And if you're driving somewhere, it's the middle of the night somewhere and it's really, really dark, pull over on the side of the road safely in a safe turnout and just get out and just look up at the sky. I do that on trips.
Make sure you get completely off the road.
Yeah, take an exit.
When you do this.
Take an exit if you're on an interstate, which I've done multiple times, really, really dark places. Take an exit off the interstate, drive a mile south to get away from the lights that tend to cluster at many of these intersections, and just sit there for 15 or 20 minutes and look at the sky, just enjoy the beauty that you have with the Mark I eyeballs. So anyway, answer the question. The question is, what's your favorite constellation and why? Somebody's going to win. And anybody listening to this can enter. We'll take answers up until, to give people time to think about it and try and craft the responses, noon Central Time on June the 10th, 2021. So noon Central Daylight Time tomorrow. We'll take answers up till then.
Great. Okay. All right. Well, Ken, thank you very much. Congratulations on your 40th episode. That's great. We're going to take a little intermission break here and come back with Cameron Gillis for his 5th install of Camstronomy, his ongoing journey in his personal sky survey. So I think it's going to be, it's always interesting and excellent to learn about how Cameron organizes himself and collects, all the information that he does about the objects he looks at. So we'll be back in a few minutes here.
All right. Hi, everyone. Welcome to another episode 5 of Camstronomy Sky Survey. So let me start off by sharing my screen here. So basically, I wanted to pick up where we left off. Let me, so this is just a quick readout on where we are at. I have logged almost 3,000 visual observations over the past year. And that, of course, that number continues to climb. And my approach is I start off with the visual observations, kind of constellation by constellation, record all my observations. And then I go through and then I've classified out of those 3,000 objects, I've classified almost 700 that I consider what I call best and brightest. Doesn't mean that they're super bright. It means that you can pretty much, I've categorized it as something that would be visible or achievable to see in a small telescope. I'm using an 8-inch Schmidt-Cassegrain as my observing equipment, but I'm following through with observations with the smaller telescopes to validate these what we call best and brightest objects. So I've done that, and then that's an ongoing thing. There's still a couple of constellations that I need to finish up. I've saved the ones close to the pole as last because I can see those any time of year, and I've been focusing on the lower ones to the horizon and that are on the meridian that are moving by fast through the seasons. Because here in Seattle, where I am based, a lot of cloudy nights and it's difficult to catch. So I try to take as many observations as I can on the constellations that are near the horizon, southern horizon first. And then basically, and then I started adding smartphone images to back it up. And what I'm doing here as part of our sky survey is I am going through this list of 700 best and brightest objects and doing smartphone images to basically recheck the observations and also be able to share the viewing experience with this audience and give people some inspiration on what on going through all these objects that I've surveyed and see what is achievable in a relatively light polluted sky. I have Bortle 6 to Bortle 8 skies in my backyard. So that's what I'm doing. And then I've done 21 so far, and we're on episode 5, and I will continue to do this. The pace I'll be sharing this at is around 10 per session, 10 per week. And we're just going to start to go through the seasons, constellation moving from west to east. And the way I figured is after about a year, I should have about 800 of these objects covered. So, we, it's a long process, but and then as I'm doing that, I'm also adding some more enhancements. I'm adding astronomy camera. I'm going to be adding. I've added an ASI 294 MC. To enhance, to kind of augment my smartphone observation images, and I'll be kind of backfilling and overlaying those and doing comparison between those, so you can see a little bit deeper and see maybe some of the fainter objects that are also in the same field of view as these brighter objects. And the other thing I'll say is right now, I'm somewhat limited with what I can do around zenith because I'm using an alt-az go-to mount, and so that limits my timing. So I either get the constellations earlier as they rise from the east, or after they pass zenith, I get them later on when they're setting. So that's kind of restricted what I can do depending on the timing. But I'm looking forward to getting an equatorial mount, the PMC-8, the Exos 2, later this year, and then that will just make it that much better, because as we all know, when you're taking images and doing observations, zenith, that gives you the least amount of atmospheric dispersion refraction, and it gives you the best seeing conditions because you're looking through the thinnest part of the atmosphere. So that will really help, augment. I have noticed during my survey of these objects that, the objects on the southern horizon are very, very difficult. Like, for example, I can pick out 13th magnitude galaxies when they're closer to zenith pretty good, because even though I have light pollution, the thinner atmosphere doesn't disperse the light as much. So I actually can see fainter objects closer to zenith. And for example, I might have challenges with 11th magnitude galaxies closer to the horizon. So that's another thing to factor in as you plan your observations and do all this. I might go back and re-look at other objects depending on the conditions, just to see if some of those ones that were maybe more interesting, but they were beyond my reach on particular nights, I can go back and collect those. So that gives you a little bit of sense of how I'm structuring this journey and sharing it with you all. So if I continue, where we left off last time was on Eastern Virgo. So if I go to my here's my list of 697, almost 700 best and brightest, and we started in this grouping here. And so if I zoom down, we were starting to go from east to west, and we ended up, the last observation we shared last week was M5. So we're going to continue. That was in the Serpents. Now we're going to go, and we're going to go. We look at this. Oh, let me just a little bit of delay here. There we go. So as you can see, I'm going to start to go through Hercules here, and these are the objects I'm going to be sharing. And I've also thrown in two of the astronomy camera, the ASI 294 MC pictures that I want to share, because one of them is the Needle Galaxy. The other one is this galaxy cluster here, the Hercules Cluster. I want to show you that was looking into a deep field, and we'll explore that a little bit as well. So this is the equipment just for reference. And so basically just I used one eyepiece all the time, a phone adapter. I used a tablet for my Sky Safari control, and an 8-inch Macassegreen alpha-azimuth, and then an S8 that it has capabilities of going to 10-second exposures at ISO 800. So now let's go to the first object. This is the Planetary Nebula IC 4593, and if we go to, we zoom in here and we look at the object information. And just to keep the orientation, and when we do the visual plate solve, what I've done is I've set the time to the same time that I took the pictures. So this was Saturday, May 22nd in the morning. So now basically very early, and so that should keep the orientation of all the stars. So if you, for example, see these stars here, this asterism, you'll see that's here, and that's the same one we see in the image here in the smartphone image. And that's how I know for sure I got the Planetary Nebula. This is quite a bright nebula. It's small. There was a question in the last session about using a higher power eyepiece. Yes, I'll do that. But as you know, every time you change the imaging train and play around with your smartphone adapter, that you lose a lot of time. So what I'm trying to do is I'm doing everything with the same eyepiece, the same smartphone, getting all the images, and then I'll go back and do another session in the future with a different power, for example, for some of the Planetary Nebula. And similarly on nebulosity, I have a UHC filter that I've just acquired. I want to use that for and use even a wider field, probably my 40 millimeter Explorer Scientific, it's a 68 degree. Yeah, 68 degree. That's a really nice eyepiece. That will give me really good with an UHC filter. I'm going to try that for some of the larger nebulae that really you can't see very well visually, but maybe with a smartphone and a UHC, we can pick those up. So anyhow, this one here, all with the same, you can see just basically very star-like. And if you look at the information, this guy is, he's 4.2 thousand light years away. So he's relatively close, right? Obviously within our galaxy. Anything in thousands of light years is definitely in our galaxy. I'm still in, we can see we're in Hercules, we're transitioning from galaxy season into nebula season. So, and intergalactic, or intragalactic, I should say, objects. So, so this is our first object besides the globular clusters that are really close by. And if I go to the next object, now we're getting back to some of the galaxies in Hercules, 6181. And if we zoom back out, that's just up here by the foot of Hercules, 6181. And if we look at that guy, it's magnitude 11.5. And that galaxy is 110 million light years away. So this guy's one of the far ones. When we were looking at the galaxies last year in Eastern Virgo, those guys were ranging from 80 million to about 130 million light years. So this guy's kind of in the farther side of that. And if you look at the smartphone image, you can see these three stars, the brighter one in the upper right of the triangle. And this is nice. I love I like seeing galaxies in triangles. It's a nice, pleasing view to be able to, you know, easily triangulate it and know where it is, and then use averted vision to be able to. And you can see that the smartphone image takes a pretty good view. You can see the central core is brighter, and it has a nice, you know, defined oval. So it's that's 6181. And the next one is 6210, another planetary nebula. So if we go back,
I wanted to read something from the audience here, Cameron. This is from Jeff Wise,
yes.
who will be sending you an email, by the way. He says, Cam is doing a tremendous job and is definitely motivating me and showing me a new way to enjoy the night sky. So that's great.
Thank you, Jeff. That's awesome. Wow,
Yeah.
coming from Jeff, that's a lot. Thanks a lot, Jeff. I really appreciate it. Yeah. I mean, this is what actually, Jeff. Now that you mention it, two things I want to say. First of all, about what you were saying. When I go through and I present this, and I actually prepare the smartphone images, it's like I'm observing a game. You go, even when I'm going through Sky Safari, I'm looking at it, because you're taking the notes, even on rainy nights, which happens a lot here in Seattle. You can really have that same wonderful experience as if you're using your scopes. You're kind of redoing, so you're kind of augmenting your visual experience. You do that, and you do the images. So I'm really an advocate of doing both and complementing each other. You know, not just being pure imaging, not being pure visual, but doing both, because that really lets you get the maximum enjoyment all the time, and really study the object and learn. So yeah. And then the other thing I wanted to say is, earlier Kent was talking about the kind of the minor constellations, and I love those, because as I'm doing the survey, you know, some of the nuggets, that's part of one of the thrills I get is, you know, these unexplored objects that are hardly shown on the front pages, and then you discover yourself, like, wow, this is pretty good. You know, after looking at all these 13th magnitude galaxies, all of a sudden you see this, you know, this other one that's like maybe 12th magnitude, but it has a nice shape to it or something, you know, some structure. And it's like, wow, that's a nice little gem. So, or it happens to be with a certain structure, a certain asterism of stars, or a really nice sprinkling of different colored stars around it, just to make it a really nice presentation. Those are the types of things that are really wonderful about those other constellations. So, for example, like Draco is a good example I'd like to use. That one in the northern hemisphere, we have great views of Draco most of the year. But it has, like the Camstronomy Nebula, it has a string of beautiful galaxies that are I forgot the name, but there's like a series, and they all have different orientations and different types. And you know, it makes it really nice when you start to find these pairings.
Mm-hmm. And Pekka has a question. He says
Yes.
he wants to know if you use a PC at all in the inquiring process.
Yes. So what I do is on all of these images that we're taking here is I set it up so that I have Team Viewer connected to my smartphone. So if we could, let me just go back here so I can explain it better.
Okay.
So I have my tablet is actually by my computer. So I use that Sky Safari Direct, and that's so I have the Wi-Fi in my Evolution mount that is actually connected to my home network. So that and then I use my tablet by my computer to control using Sky Safari, control basically the sky survey, object by object. And then on my PC, I use TeamViewer that logs into my S8, which is on my phone adapter at the end here. So I plug that guy in. And what I do is, because you're having TeamViewer and you're always having the smartphone on at all times, it drains the battery pretty quickly. So if you didn't have it plugged in, you basically lose the power because you're doing TeamViewer, you're taking pictures, it's using the screen. It basically uses battery probably in less than an hour. So that's not sufficient. So what I do to circumvent that is I plug in there's another USB port on the Evolution, but you can use whatever. You can even just tether in, USB-C, and then I plug that in, and so literally that provides a direct power, so it is always at 100%. Then on my PC, I basically have peace of mind, and in my office, I can have my tablet connecting all the Sky Safari control, and then I use my smartphone through TeamViewer on my PC to basically look at the pictures and control this the screen directly. So hopefully that helps answer. And again, I'll go through that again. I had a session earlier, Pekka, which walked through that, but we'll do that again another time, because I have some more updates, of course, on my other imaging train that I'm setting up. So yeah. So continuing along, so this, when you look at this planetary nebula, it looks great in the eyepiece, but you need a higher power. It looks like a bright blue star here in this smartphone image, but it's a really nice object to view. So 6210, and if we go to the where is it? Oh yeah, go to the here. Let's see how far this guy is. So he's sorry, that's 6181, wrong one. Let's click on it. So this is 8.8, magnitude 8.8 is a very easy, you can easily pick this out with a small scope. The planetary nebula are a great place to start for small scope owners. I highly recommend, because you can really push the magnification, but also you can push, you can really see it with a direct vision, a lot of the planetary nebula. And they have a nice color, distinct color, usually blue or green, or sometimes a grayish blue, grayish color. And a lot of them have central stars. Some of them don't, well, many of them don't, or they're too faint to see in a small scope, but at least you have a very nice object to see. And they're usually in a denser star field, so you can easily triangulate the location of the planetary nebula. So if I look at, sorry, let's look at the information again. So this guy, let's see how far he is. Doesn't say how far he is. Oh, here we go. 6.5. So 6,500 light years. So it's a bit further. So here's an example. This planetary nebula is actually brighter than the other one that we saw earlier, but it's another 2,000 light years away. So it's further away. So that's an interesting fact. Oh, sorry. Next one, we go back to the presentation. Back to galaxies, 6482, and it makes a nice triangle with these two stars. You can see the orientation. We go to zoom back out here. So now we're already moving to eastern Hercules. So 6482. And click on this guy. He's a magnitude 11.4 galaxy. And let's see the distance. This one's really far. Whoa, 200 million light years away. So it's quite bright and distinct, but yet it's the furthest one out of the galaxies we've seen so far. It's actually the furthest one. Yet it's very, if you look at the image, if we look at the image here, it's actually very defined. It has a very strongly defined core, and it has, yeah, and it's easily found. So that's an interesting object. This one I really like, 6500 and 6501. I love when they have pairs of galaxies that are kind of equal brightness. If we zoom back out, that's coming down here. So there's a nice pairing here, and it's near a bright star, so that makes it easy to find. So you can see what I love to be able to see, you know, in Sky Safari, you see these string of stars, and it's exactly the same pairing with these double stars on both ends. And then very clearly, you can see the two galaxies. The one on the left, obviously a little bit smaller. Even the image shows that according to the scale. And then you have a well-defined core and a little bit of, you know, oval shape to it. That's nice. 6548. Let me zoom back out. 6548 is in there, close by. Oh, actually, before I move to those, these guys, let's take a look at their brightness. They are 12.1, magnitude 12.1. So see, they're actually fainter, but they're very distinct. And it's and they are 150 million light years. So we're getting pretty far. And I think they're probably the same. Let's see if they're both the same distance. 150, yeah. So both of them are actually neighbors in space. So that's cool. truly a pairing. Sometimes you get these galaxies that happen to be in the same field. They're close by, but they're very far apart in space. So like, here's an example. I don't think we can see this fainter galaxy. This one here is 11.76548. So let's go 6548. So this guy's 11.7, nicely defined. It's in the kind of in this triangle along the long side of the triangle. You can see nicely defined again, and it is magnitude 11.7. And if we look at the information there, see, that's a much closer, 74 million light years. So it's one of the closer ones. Yet, if we look at its neighbor, which is beyond the imaging of this of the smartphone, but maybe it's going to be within the field of the ASI 294. If I go and view that guy, see, 330 million light years away. Wow, almost magnitude 15. So that is another, you know, once you start to get into 15th magnitude and beyond, you're talking super far. It's another area of space entirely. Okay, let's go to the next 16555. So this one here is a pretty faint one. You can see these two stars in this triangle and another triangle here, but this one is very hard to, you can't really see it very well. It's very diffuse. But if we go here, see, it's a magnitude 12.4. But I was able to, with averted vision, this is an example of smartphone versus visual. It's interesting to note certain objects, your averted vision, your cones in your rods or cones. I think it's cones, right? Rods are in the sharp ones in the center that detect color. Your cones are the faint. You use averted vision, and so those guys, you can actually pick out you're more sensitive to these to the galaxies that don't have a well defined. They actually pop out when you use averted vision. Compared to the smartphone, you're at the mercy, of course, of its calibrated sensitivity of the game. So, but you can still see it a little bit there. And let's see the specs on this guy. Again, he's at magnitude 12. Oh, sorry, it's a magnitude 12.4. So one of the fainter ones we've seen. And if you look at that guy, 120, yeah, so kind of average for distance. Now we move on to 6610. Zoom back out here. Almost finished our run here. So 6610 is 11.9, so one of the brighter ones, and it is 130. Yeah, so it's one of the pack. So a lot of these guys are around the same distance. But this is a good picture. It has a nice chain of stars here, and then you have a nicely defined elliptical with a nicely defined core. I love that. And then moving to 6661.
Jerry or Jerry Hubble.
I think this is the last of the galaxies. Let's take a look in Hercules that were bright enough. So that's a magnitude 12.3. And if we show the information, it's a little bit further of the pack, so it's 210 million light years away. And if we look at that, it also has a neighboring galaxy, 6658. And if we click on that guy, 6658 is, it's just a little bit delayed here. According to this, it's actually, here's an interesting one. 6661 is a 12.3 of the galaxy, okay? And 6658 is 11.8. And I love this. Here's another example where, you know, magnitude, you have to be careful with that, because you can see that it's 6661. You can barely pick it up, even though it's 12.4. You're looking at the size, you'd say, you know, 6661 should be more diffuse. However, the orientation of the galaxy is such that you can see the core, which has a higher surface brightness, and whereas the 6658 is more edge on. So as a result, even though it's so brighter somehow, and I mean, this is an example where I'd love to validate this some more with some more imaging and some more observations. But 6658 is somehow brighter, but there's enough of an edge on that it dissipates and diffuse, makes the image brightness quite a bit more diffuse, and you can barely even, I can't even see it actually here. But it's really, that's a good example where you have to be careful when you're setting your observations up, that you say, okay, I want to see everything down to 11th magnitude or whatever. You'll find out that many galaxies that are 10th magnitude, or some of the other ones, like for example, dwarf galaxies in Leo and that, are super diffuse. There's no chance of seeing that with a, you know, if you have any light pollution. So that's the reason. That's another reason why I'm doing this sky survey, to help everyone to kind of see what's a good bag of achievable objects to help reduce that frustration. So that was that, and let's move on to the next one. Now we're gonna end it with a really nice bang. So we got M13. I'm really happy with this picture of M13 with the smartphone. You know, if I zoom back, if I zoom in, that's pretty good. You know,
that's very good.
The stars are square. You know, but mostly round, right? And by the way, this is not even the smartphone. This is more to do with the mount, because it's in a 10-second exposure, the mount and also the uneven image, even seeing conditions, I've noticed that it causes the stars obviously to bounce around, and you get these strange shapes. But I'm pretty happy to be able to get this with a 10-second exposure, and being able to see M13 nicely. So if we go to our familiar territory of M13, in the star chart. As we all, if you don't know, the way to find M13 is you have the keystone here, which is a very pronounced asterism of 4 stars, roughly equal brightness. And what you'll want to do is on this long one here on the right, on the western side, about a third of the way down, that's where you're going to do it. So if you have a Telrad or however you're doing, that is a wonderful galaxy, a wonderful cluster to be able to see with any size telescope. Just a beautiful object.
And if it's dark enough, you can see it with the naked eye.
Yes, absolutely. Yes, it looks like a fuzzy star.
Yeah.
And if you zoom in, another thing that's nice about this characteristic is it has these 2 stars off to the side, so it makes a triangle, and you can see those right here. So it makes a really nice view to be able to see those. But there's another bonus, which is the next slide here. There's a galaxy off to the side called 6207, and I remember when in my early times of astronomy, this was always like, wow, there's a galaxy in the same field of view. That's cool. But I always, you need a huge telescope to see it. But actually, you'd be surprised. Like Scott has said, go to a dark sky, even a small telescope will actually pick this guy out because he's quite bright. If you click on 6207, it's 11.3 magnitude galaxy, and it has a good surface brightness on an orientation. So it's a really good object. So I encourage anyone, check out M13, easy to find 6207, look at this triangle and go the opposite direction. So you can see how it makes like this type of shape. And then you'll find 6207. Now let's look at the facts. So 6207 is, oops, sorry, that's the star. 6207 is 11.2 magnitude, and it is, see, it's one of the nearer galaxies, 50 million light years away. So it's 50 million light years away, whereas M13, magnitude 5.8, very bright, like Scott said, naked eye in a dark sky, where you can get this magnitude 6. And then if I look at the information, it's 23,000. So because it is an extra galactic object, the globular clusters are kind of around the galactic, outside the galactic plane. They move, they're on the north, they're on both sides away from the main spiral arms. They're actually almost like little galaxies in themselves. They tend to be a bit further away because a lot of the objects that we see in the galactic plane are blocked either that are in front of the dark nebulosity that makes up the spiral arms. So a lot of those tend to be thousands of light years. But when you start to see globular clusters, they tend to be further because you're actually seeing away from the galactic plane. So you're not having obstruction of dark nebulosity, and you get to see these guys. So he's at 23,000 light years away. And so that's the that. And then I wanted to end it with my couple of pictures from my new ASI 294MC. I've shared some of these before, but I wanted to start introducing them again in the context of our sky survey. And here's one, the Needle Galaxy. And what I wanted to highlight here is 2 different pictures. One is, this is with the ASI astro imaging camera 294, and this is with my S8. This was with 30-second exposure.
Wow. And
this is a 10-second exposure. and I want to do more of this because it kind of showing you in the evolution, the steps where you can still get a lot of good stuff from a smartphone. Like you can still see the dust lane, right? You can see that, you can see both sides. You can still see the stars and a lot of the same. So it's really fascinating to be able to see the same image and its evolution, and then also representing different things you can see with the scope. The other bonus you get with the astro imaging with the 294 is that because it's more sensitive, look at this. There's a couple more galaxies in view. You can see this one over here, and you can see this one here. And if we look at that and go back to our Sky Safari and show you guys what this what is. So you go to the Needle Galaxy in Coma Berenices. Oops, that's gonna. It always takes a little pause here. There we go. Okay. So we zoom in here. And actually looks like I need to change my deep sky to a fainter actually. Yeah, see? So let's go to 16th magnitude. Or 16.8 now. So now you can see this galaxy here, it's a magnitude 14.4. And if we go to the object information, that guy's at, see, it's actually pretty close. That's interesting. 36 million light years away. And then the wonderful, glorious Needle Galaxy is, see, so you know what this seems to indicate. 39, and this guy is, I bet you these guys are companion galaxies. I bet you this is just like our large and small Magellanic Clouds. I bet you these are little dwarf galaxies that are neighbors to the Needle Galaxy. This one at least is, because it's very close, but you can see it's quite a bit smaller. So that's an interesting thing. The facts that you can, as you do your observations. So let's take a look at this one here. This one's a magnitude 15.1, and it's a
faint.
Yeah, very faint. And if we look at that guy, that one's now clearly not in the same neighborhood. 310 million light years away. So that guy is legitimately super far, not even close. But it's interesting. It's in the same field, and you can pick it out. So just similarly, the way I'm doing it with the smartphone, what you do when you get a more advanced camera, and obviously you can go to the nth degree here. You can go to even higher end CCD cameras or whatever that are really expensive, and then you can get even more fainter and get deep fields. But the nice part is there's plenty of enjoyment with just a smartphone, and then you can augment that later on with a dedicated astronomy camera and see some fainter objects. So this is the Needle Galaxy and its neighbors. And then this one, I really love this one. This is the Hercules Galaxy Cluster. And you can see tens of galaxies in this field of view, all the way down here. And what I did is I took a snapshot.
Oh, yeah.
We'll zoom into this area. To find this, you want to look for NGC 6401. Okay, and I'll show you that in Sky Safari. And here's the actual image. You can see all the galaxies. So now if I flick back and forth, sorry, I'm gonna
like a blink comparator or something.
A blink comparator, exactly. Sorry, I'm trying to do this a little bit better. Let me use my keyboard. That will be better. Yeah. So if I go back and forth, yeah. So you see this triangle of stars here. So look for that triangle of stars. There's that triangle of stars, and you can see that these are those galaxies. And if you go here, look at all the galaxies. You can see those ones. So I was able to do visual plate solve after the fact and find out where this was. And if we go to Sky Safari, there we go. Let's zoom back out again. Just look for clusters of galaxies. So if I just keep on going here, you just see a density. I was like, oh, there's a bunch of galaxies here. That's where it is. So basically, just off of Hercules foot, this is your Hercules cluster. And if I zoom in, and then there's the same patch. So if I click, see there's 6041. That's a magnitude 13.3. So it's actually quite bright. That one is. But here's the neat part: is if you zoom in, I'm gonna go back to here again. Zoom in. You see this galaxy right beside it? There's two more galaxies. Now, if you go back to here, see?
Oh yeah.
That's a magnitude 15.4, and actually I probably can go even fainter here. Let's see, that's the faintest here. Let's go to, let's go all the way. Yeah, there we go. See, so now you see these guys. So you can actually see there's a group of 4 galaxies. So let's take a look at some of those just for fun. we could spend all day, of course, doing this, but this is a magnitude 17.4 galaxy. This thing here, if I zoom, this guy here, there we go. That's a magnitude 17.4 galaxy right there.
Wow, that's faint.
And so if you look at here, that guy is 470. So it wins the game tonight. It's 470 million light years away. So it's really far. And then let's just check out these guys' kicks, and then we'll call it a night. So this one here, 13.3, the brighter one. That one's at 500. Oh, it's even further. See, this is cool. So it's actually brighter, but it's further. 510. Oh my gosh, 510 million light years away. How about these guys? Are these guys companions? Let's take a look. 15.4 magnitude. Oops. There's a computing delay. 550. So there you go. So I bet you that's a companion galaxy. And then same with this guy here. Let's take a look. 17.7, magnitude 17.7. And we'll go to that guy, and he is 490. Yeah, he's probably not a companion. He's a good 20 million light years away. So maybe at one point they were neighbors. And then this guy, another 17.4, 470. So yeah, so those guys might be paired somehow. So anyhow, that's what I wanted to share today.
Very
so,
cool. You took us deep. You took us very deep.
Took you deep. yeah. So so yeah, we'll continue into Lyra and some. We're starting to get away from galaxies into the Milky Way, looking at our local group here, and we'll continue the sky survey. There will be still some more galaxies that I have in the future, but we will continue down this journey. So thanks everyone. Hope you enjoyed, and let's continue the sky survey together.
That's cool.
Cameron, I have a question.
Yes.
Have you tried to stack these images, or does the field rotation and the movement, just the time exposure, not lend itself to stacking?
No, that's good. The quick answer, Kent, is no, I haven't. These are just single exposures, and I only have one image per and that's all I've done. And I am what I'm going to do in the future for some areas, Kent, is I will do some stacking as I get more adept. But my purpose right now is for the sky survey to I actually want to only take, you'll see these images are quite noisy. I'm not doing any image processing because, as you know, once you go down that path, it's very time consuming. Mm-hmm. So yeah. I'm choosing, there's two different ways you can spend your time. You can do a broad brush, or you can go deep, right? And so I'm going to do both, but I'm going to do it in a kind of a way of keeping myself sane. I'm going to do it in chunks. I'm going to do it very slowly, enjoy the journey. So the stacking part is going to come. I've played with it a bit before, but realistically, when I'm going to do this sky survey, I'm going to get a process down where I can try to take one image as clean as possible, do minimum image processing. And so literally, I get a process down where I can really continue to take images and continue to take different objects rather than just focus on one or two objects and then perfect those. You see what I'm saying?
Yeah, you're saying, as Frank Sinatra said, you're going to do it your way.
I'm going to do it my way. Yeah, that's right. Yeah. No, but I really like that, and of course I will start to do some of the stacking as well for certain areas for sure. But for now, I'm going to optimize the single shot approach.
Excellent.
So thanks. Any questions?
Becca has one.
Let's see. Well, Pekka, yeah, we already. Well, he says hi. Are all those information you showed of galaxies in Sky Safari 6 Pro?
Oh, yes, yes. So
Mhm.
what I did is I put it, and for the purposes of the presentation, I'm using an emulator called BlueStacks. So I'm putting my Sky Safari Pro, which is native Android, of course, in an emulator on my PC so that I can easily share the screen and we can navigate together. But when I'm actually controlling my computer or controlling my telescope, it's much faster and much easier to just use your tablet because it's native and you don't have to do an emulator, which is not very efficient. So that's what I do. But for the purposes of our discussions here, yes, it's the same Sky Safari 6 Pro on both my laptop and my tablet.
Excellent. Okay.
Yeah.
All right. And since Pekka had chimed in there, I do want to give a shout out to Pekka. I'm going to share my screen here.
Yes.
Let's see. And what do I have here? Here it is. Pekka won recognition from the
Oh yeah.
from the
That's
Swedish
awesome.
National Space Agency. This is the equivalent of NASA in Sweden. Okay, so it's a big deal, and they had some sort of a competition, and I guess it was images. It might have been different images, but this was of the moon, and so they gave a huge, full page thing to Pekka. And that's his moon there, his first quarter moon. And I believe
Beautiful
that this
picture.
is information from the Swedish National Space Agency. But other comments here look like they're from Pekka himself. This is all translated into English, but he said the most fun to photograph in space, he says the silence, the freedom that you capture photons that have traveled millions, billions of years in the empty, cold space. You capture its journey in your camera sensor, and then you can look at the information that the photons traveled from there together simultaneously emit in the image forever. And it's just so cool.
Wow.
This last question, how does it feel to be one of the winners? It feels so wonderful. It's an acknowledgement and proof to me that the hours and nights spent on my hobby have paid off. It gives me more motivation to continue, but on a higher gear. Well, that's great. Pekka,
Awesome.
Congratulations on that. And then the last thing I wanted to talk about a little bit is that there is going to be an annular eclipse tomorrow. And part of it will be visible from the east coast of the United States. So you'll see partial eclipse activity. This page from NASA, and I'll share it with you in chat, will give you the path. If you're somewhere in the world where you can actually see this, that's great. But use safe solar filtration, and if you've never photographed an annular eclipse, there is lots of information about it on the web. But practice safety at all costs. Because during an annular eclipse, you still are seeing surface of the sun at the edges, and so that doesn't mean that there's any time that you would not use a safe solar filter. So
Protect your Mark 1 eyeballs.
yeah, that's right. That's right. So I think that is the end of our program today. We had a nice mix. Tom Menegini, I want to thank you again for being on our program. Cameron, great program as well. Awesome. Annie, thank you very much, and congratulations on your 40th episode, Kent. That's great. Kent has done many other programs with us, and he'll be back with us tomorrow with a new program called On the Wing, and that will be with birder and amateur ornithologist Dan George. And so we'll be doing that at 4 o'clock tomorrow, and we will still have our open Go-To community program on Thursday as well. So, but tonight we have the 49th Global Star Party, and that gets started at 8 Central. So we have a nice lineup, including, I think I talked maybe a little bit earlier in the program, 2 11-year-old girls that have gone to space camp. One of them is Libby in the Stars, who has done roughly 40 presentations with us. And then a newcomer, her name is Sabella, rhymes with Capella, Sabella Burlingame, and she is going to talk a little bit about her experience at Space Camp, which she's going back to again this year. So these are young ladies that are probably the future of space exploration, because they are just really on fire about it. So hope you watch that. Deep T will be with us. We've got Kareem Jaffer, David Levy, Jerry Hubble will be on, Cesar Barolo, Maxie will be on as well. We're going to be missing Cameron. He's usually on. But anyways, we'll see you in a little bit. Thanks for watching, and keep looking up. Here's the Explore Scientific iExos 100 Equatorial Tracker mount. We've got it mounted up here with a digital SLR that's got the dovetail plate here. We also have it kind of mounted on our extra heavy duty tripod. But this whole thing is operated remotely. You can see Kent's operating it with his Apple tablet here, but it'll run off a Windows tablet or an Android tablet. What do you like about this whole system, Kent?
I find it very intuitive. It's very quiet. Like any go-to system, there are things to learn.
Sure.
But once you learn those things, it makes it really easy to find stuff in the sky.
Sure.
Now, this is running our Explore Stars app. If you're going to do astrophotography, you need to be running it with a planetarium program hardwired to a computer.
That's right. So this runs wireless, wired, okay? It's super versatile. It not only has go-to capabilities, but you can also add a guide scope with an auto guider CCD type of camera onto it. So, and the thing that you're going to really love about this is the price of this instrument, which will fit neatly into your budget, I'm sure. So check it out, look online, check out the specs, give us a call if you have any questions.
This doesn't hurt anybody.